Yeah, so I'll be talking about a diversity promoting GAN. So that's not like the diversity we just discussed, human diversity, but we're talking about text diversity today. So the reason I'm presenting this is I had a chat with Jay during our last meeting, and we talked about, GANs in general, and then we talked about applying GANs to NLP, and I hadn't really looked into that before. So that was a very good prompt to basically look at how this is done and why this is done. And that's what I'm going to be talking about today. I'm going to be presenting the diversity promoting GAN today, which was first presented at the MNLP conference in 2018. And yeah, I guess I will first start with a little introduction about what this is about and why we should care. So really the main premise is that a lot of text generation models currently produce very predictable, boring, repetitive text. I think we've all encountered this in real life, right? If you go and use a chatbot on some website or something, you'll get a lot of like, I didn't get that, I'm sorry, or, could you please do this, or thanks, that. It's very oftentimes one-dimensional. And especially if you are in a position where you have to interact with such an agent repeatedly, that might get very boring, very frustrating very quickly. So, really what we want for text generation or, a conversational agent or so on is much more human-like, fluent text that also seems like a more friendly, less robotic interaction for the user. Usually standard training is done for such a generator via maximum likelihood estimation, which is basically what results in this very repetitive type of text that we're looking to avoid here. And what this paper introduces is this DPGAN that aims to rectify that by assigning a low reward score for repeated text or very short text, and a high reward for varied, fluent, diverse text. And on top of that, also proposes a discriminator that can allegedly distinguish better between repeated and novel text to tie in with that and essentially build like one whole system. So the structure that I'm is what I'm going to kind of lay out here is, first we have the generator, the text generator, which is a sequence-to-sequence model using a hierarchical LSTM encoder that generates multiple sentences. So that's something you'll see in the example sections. When most comparative models give out, short 5-6 word sentence answers, this kind of, goes on a bit beyond that, gives us, 3-4 sentences of, 10 words or more, something similar. And that is coupled with the discriminator, which is also based on a language model, which is not usual. And this is built on a unidirectional LSTM that is aiming to discern between generated text and novel text, essentially. And the output of this is cross-entropy. And this cross-entropy based reward is then used for the generator, essentially. Oh, I did not mean to do that. Sorry. Okay. Sorry about that. Here we have the cross-entropy based reward, which is a negative log, essentially. Here we can see, this will be relevant on the next slides, Y is the teeth sentence with the cave word. And this is used for adversarial reinforcement learning for the generator G. I'm going to keep it a bit light on like mathematical specifics. I'm trying to get like the general idea across here. And yeah, then we look to essentially maximize, or this paper looks to maximize the reward for, as I said previously, real world fluent and diverse text, and minimize it for repeated short boring text. Here we have the whole word and sentence level reward kind of visualized. So you can see the G generator and D discriminator on the right-hand side, and you can see how the sentence level reward and the word level reward feed back into the generator, because the overall reward is split into a sentence level reward and a word level reward. So you can see the formulations on the slide here, and essentially the sentence level is averaged out, an average output words within the sentence.
Philip, I don't know if you have your suppressed background noise on. on Zoom?
I
So if
do.
You do? All right. Okay.
It's literally right outside my door, unfortunately. So there were three data sets we used. There was the data set, data set, and open subtiles dialog data set. The numbers behind is the numbers of train, validation, and test, prompt, and target pairs that we used for. And then the model was applied to two different tasks. So essentially, review generation task with initial prompt, and then dialog generation for the corresponding data sets. And then it's compared to baselines, which are MLE, blue, and SecGAN. Also, that was also compared to a PG blue one, which was again sequence to sequence, but trained via policy gradient using blue as the targeted reward. And then the SecGAN, which is another NLP generation gun that was published previously, so it's more of a direct comparison, I guess, with that. Then on the right-hand side, you can see some very nice examples that I think visualizes what so you have input prompt there, right? And then you can see how, you have a model that's generating a very short response that, is very similar across the communities. One of my favorite places to eat is the prompt, and then the generated text is for the MLE, like services grade, which, there's nothing wrong with that. And all the examples basically get across the same sentiment. It's just, how that is done, the diversity of the text, how engaging it is to read, and how robotic it sounds, right? So we can see that the DPGAN, usually presents 2 to 3 sentences of very real-looking, very diverse text. And I think if you were to see that on Yelp, for example, this is using the Yelp data set for the generation here, you wouldn't be suspicious about that being a robotic generated text. Beyond that, this was evaluated using 2 different methods, one being automatic evaluation, which is done here. So basically what this automatic evaluation is they basically just looked at for their 3 different data sets. They checked the number of unique generated tokens, unigrams, bigrams, and so on until sentences. And then, they say that the higher the better, which I guess if you're looking at pure, text diversity is true. And here we can see that the DPGAN outperforms the other 3 methods pretty substantially when it comes to just generating more unique tokens, I guess, and also, unigrams and so on. We can see that there's 3 different DPGANs there, the S in the brackets, the W in the brackets, the S and W. So this just means that they are considering, just the sentence reward, just the word reward, and then both rewards as shown in the figure earlier. We can see that when we look at the SW, for all the unigrams and so on, it clearly outperforms all the other models. So that's really nice to see, sometimes quite substantially with, over 10 times as many, bigrams or so on, and sometimes just as many as 2 times. But, really when we look at sentences is where it really outperforms. And then we have the human evaluation, which it was a bit odd in the paper that just said humans who are experts in linguistics reviewed this, but it didn't give any concrete information on how many or any data about the annotators there. But I guess we'll just have to take their word for it. They reviewed 200 random sample pairs from the different models and the different data sets. And they essentially ranked it based on 3 factors, which are relevance, which is how related the text is to what's going on, diversity, how much specific information is provided rather than general repeated information, and fluency, essentially, do you think this is produced by a robot or not? Like how human-like does it look? And then all, which is kind of like a holistic metric where they get to subjectively tell you how nice they think it is. And we can see that the DPGAN tends to outperform across all the data sets in relevance and diversity, but not in fluency, which I guess you could attribute to, if you generate a lot more text, there might be more room for possible errors. If you just generate, 3 words, I think that is a lot easier to say, oh, this might be by a human. And then finally, we have some more nice figures on the results. So one thing they did is they looked at the cosine similarity, comparing the MLE to the DPGAN when compared to kind of a real world distribution of words within the text, within the corpus, right? And here we can see that obviously it's so the x-axis is the words ranked by frequency. So the first kind of column is the 500 most common words, and that goes until, you know, the 2000th least common word essentially, or 2000th most common word. And we can see that the disparity gets a lot bigger between the models as the words become more rare. So we can see that, you know, when we look at, again, diversity in the text and having more unique tokens and words and so on, we see that the DPGAN produces a lot more varied text and a lot more words that you wouldn't find in the other models, or I guess in this case, in the MLE based model. And then finally, they essentially kind of explain this by plotting this figure at the bottom of your screen, which essentially shows how the sentence level reward kind of changes as the sentence change. So we have on the left-hand side like true data, so sample data from the data sets, and then we essentially transition into generated data, and you can see that there's like a certain saturation in the left-hand side and right-hand side of something like the SecGAN, where it essentially cannot distinguish like how novel this really is. So it can like distinguish between left and right, but it does not classify more fine, like it's not very granular, I guess, in the way it separates out the individual sentences. And then I guess the conclusion is that we saw that the DPGAN generated more diverse text, which is a lot more pleasant to read. So again, you know, having this human-like varied text definitely is very important for, you know, applications where you'd have a human interact with this sort of generation on a continuous basis, or at least more often. Because again, if you're thinking of these types of, you know, have a chatbot for like the health services or whatever, where you have a nurse or something, you obviously want something that is a bit more engaging, that keeps them focused, that keeps them happy, right? And this is again how this kind of relates back to Kappa. When you look at kind of human AI interaction, having more diverse text is more engaging, obviously, and that's what you want from you know, long-term users who you want to keep happy or want to keep engaged with your system. And then also kind of having like better fluency and so on just provides better usability in general. I mean, I'm sure, you know, we've all used the chatbot on some website and we're like, oh, I'm not really too sure what, you know, what he's trying to say to me. You know, it's so short, there's not enough context perhaps. So again, this could be really useful and provide more value there to a customer or a user. Finally, the code for this is publicly available, which I thought was really cool. So you can check that out. So it's nice to see. And yeah, that's it. Thank you very much for listening, and sorry about the whole construction work outside my door.
Oh, Lorenzo, you want to say something?
Yeah, I was. Can you? I mean, first of all, thank you. I didn't know about this work related to GANs. Can you go back for a moment to the slide where you had like the example from DPGAN and the, what is it, the MLE? Do they like explain why the other methods like produce so little text? I mean, it's just that either DPGAN, they let the generator run, let's say, run for longer and generate more text, or it's because like the other methods for the same input, let's say, produce, let's say, I don't know, a handful of words and then some sort of like a bunch of padding empty characters.
I don't know. Okay, he's not drilling right now. So what I said is that's just different reward philosophy, right? So you have something like the MLE, which is just trained to get the maximum likely outcome essentially, and the DPGAN is trained to just basically spit out as many words as possible that are still somehow fluent and like human-like and readable and so on.
Are there any parameters that determine the output length for any of those models?
No.
Okay.
Okay, then it's. I guess I get the point, but with the reserve seems like just the generator for the DPGAN seems just to be bigger in terms of output, and that's it. Okay, that was like my one curiosity.
And I think Gauler has a comment as well.
Yeah, actually it's advertisement. Actually, we have a demo for text generation. Yeah, it contains both say the GAN, the pre-trained language model, the variational autoencoder, and sequence-to-sequence framework. Actually, I think the code is written in a good manner. And if you want to run some experiments on say many text generation tasks, you can just use this toolkit. I think it's easy to pick up. Yeah.